Hello everyone. Today I'll be talking about my project on decentralized solar grid, designed to bring sustainable energy to rural areas. The project overview. This project leverages the Internet Computer Protocol to create a decentralized solar grid. The microgrids provide a reliable, renewable source of energy and interconnect to ensure the resilient power network. AI integration. Artificial intelligence is integrated to optimize the energy distribution, predict demand, and schedule the maintenance. And I also provide EV charging station. We also incorporating EV charging station within these microgrids located on nearby roads. This not only supports clean energy but encourages the EV vehicles also. So India is lacking on EV vehicles, so this will be providing a much reliable source for the EV. And our vision is to empower rural communities with sustainable energy while consulting the global shift of green technology. So technology and the platform. I developed this project on the Internet Computer Protocol, leveraging its decentralized network to ensure scalability, security, and efficiency by using ICP technology. We can create truly decentralized infrastructure that operates without the need of traditional centralized control. So let's dive deep into our project. So this is my homepage. So you can see that I have flexible external API, open API to sense the longitude and latitude, and so the solar radiation and luminance. So the person can also see those things. So let's go to the nearest grid. So I provide microgrids nearby the users. So the user can also see the microgrids nearby. So right now I made the user as myself, my laptop, and the user. So there you can see the nearest grid is in Coimbatore. So there is also a grid here. So the I use the Drishita algorithm to make the real time shortest path. So here you can see there are 10 locations which may be a solar panel. So here you can see they are connected in a decentralized way. So if a user wants the energy he needs, so he can just go by the software and see where is the nearest grid located, and he can also view the grid. So like now this is a microgrid, and in the future this microgrid will connect with another microgrid and another microgrid and another microgrid and forms a grid solar station which will be leveraging the power source and a reliable source of energy, and it would provide a large scale of energy that would be used by the industries and many uh, societies as well. So I'll go to the request power page. So this request power page is a dynamic page. I coded this backend with Motoko. So I give some dummy data. So Chennai, and my phone number is like this, and the time frame is about 5 minutes. So submit the request. So I gave thread dot sleep for 5 seconds. So you can see this. It takes to a payment portal. So and this payment portal is authorized by Heroku, so no one can enter dummy details as well. So I will put some dummy details for the sake of this. So amount is about something that, so you can see. So I have coded this in. I have implemented Heroku for the sorry, Razorpay for the authentication. Sorry, one second. Razorpay for the authentication. And here you can see the blog page. I made this blog page using the Viz API. So the blog page is under development, and the news page. So right now the news page can't fetch anything, but the because of it is running in internet, because they don't provide free access for internet. So I will tell what the news page does. So the news page does is it flexes only the renewable source of energy which currently appears in the globe. So I use OpenAI to summarize those things, the news, And this is the analytics. This is the real-time analytics in where the solar panels are included, and how they are managed. So these are the real-time data. So a user can also see the real-time data as well. So this is the financial research reports. This is the user reports, and these are the real-time data as well. So let's go on to the other thing, that is login. So for this authentication I used Firebase, and for the login purpose, those things I have used called Motaco for the backend. So so you can see. So right now it's still under development, and these are the five things. So purchase smart batteries. So everyone needs us batteries to if I install a solar panel, they need some batteries, so they can provide energy to some other nearby shops. They are which they are generating power by generator if the current goes off. So install rooftop. So I have given for these two, I have given a Google form because we need authentication from the authorization from the user as well. So we can't sorry. So we can't go everything in backend or the page itself. So we need some support from the user as well. So we will call them manually, and ask the things they need. So if they want to become a supplier, so they want to become a microgrid, so or they want to join in the microgrid, so they have to fill these details. So we will go manually and connect them and include them in our software. And the solar maintenance, so this is the maintenance page. So if they have any issues in the solar panel or those things, we would help with those things as well. And smart meters. So coming to the smart meters, this smart meter is an IoT device which helps the user to know, and us to know how much power he has used for his own sake, and how much power he has traded. So this is about everything about trading, and making a reliable source of energy. So the user trades some amount of power. This will be recorded in this IoT device. So this is a real time device. Like it is still in working condition. Like there are many devices like this. So there's no problem. There's a real time IoT device like this. So this page will be in development. So the user sees the how much power he have traded. So and it will be updated in the software. So how much power he would traded, and that much amount he would get. So this is about energy trading and energy sharing. So the users also getting some benefited by this. And EV charging stations. This is a thing that if the microgrids come into action, there will be several microgrids in India. So by this way, we can integrate one microgrid with one charging station. So we can plan one microgrid to one charging station. So in India, 77% of the highways or the roads or the important roads, though they travel in the villages, like between the villages. So what is the main reason that India has less EVs? Of course the price are high, but I feel that there is no proper charging station or reliable charging station nearby them. So they can't plan accordingly to make a long trip. By this way, every villager will have a charging station, like a petrol bank. So this would encourage those things. So I have implemented K-means algorithm that makes a cluster of the original location. So if I am in indoor, I don't have to make every locations. Like I don't want to code every locations in my front end itself, because I don't have any charging station right now. So if this project comes to future, the charging station would appear like this. So I made these things in a K-means algorithms to make a visually appealing things. So the cost effective solution, low cost charging options help reduce the overall cost of the EV ownership, and This will also encourage the EV owners to reduce the cost of the things. So you can see it flexes the live location, and right now it is not showing the solar luminous those things, because it's not flexing everything in internet. It would run in the local host, but I have to further go and do something for this. So in future, right now I have implemented smart contracts for the and smart contracts, and I want to implement tokenization so that it would be a better, and ICP coins, that crypto coins in future, and integrating AI for the data visualization and everything. So the conclusion would be, in summary, this project combines advanced technologies with focus on community to create a sustainable and interconnected future. And we can make a significant impact on both local and global scales. So, by integrating advanced technology like ICP and A, so the challenges I faced was, uh, I don't know Motako to code. So the backend was a little bit tough for me, but I have a better experience in ICP and made the project in a decentralized way. So everyone in my college loves this project. So and love the technology of the ICP. So thank you, and